So we're going to need to be able to show algebra tile multiplication. So in this case, we have this binomial 2x plus 1 times x plus 3. So I've shown in the horizontal 2x tiles on the outside plus 1. That represents the side length, the horizontal side length. And then vertically, I've shown 1x plus 3 ones as the vertical side length. And when we do that, the product or the answer is going to be the space in the middle. So we're going to have 1x squared, 2x squareds in that space, and then we also have that thinner space here, which is going to be our x tile. So we have 2x squared plus the x. I'm just going to shade this in to show that it's positive, since we have positive times positive. That becomes 2x squared. We also have, in the space below, we have 1x here, another x here. We have the extra 1 space here. And then we have 3 layers of that. And that leaves us with, then, if we count it all up, we have 7 x tiles. They're all positive, since it's positive times positive. So it becomes plus 7x. And then we have the 3 ones tiles, so it becomes plus 3. Okay, so that represents the answer to our multiplication, and we need to be able to express this with the algebra tile pieces. For lowest common multiple and greatest common factor, we're going to do the greatest common factor first. The greatest common factor tends to be a bit easier. And with the greatest common factor, we want to know what is the biggest number that divides into both. So we can see that for 12 and 9, the biggest number that will divide into both is going to be 3. When we look at it from the factor perspective, okay, let me get rid of some of this. We have in red, 12 is represented by 3 times 4. 9 is represented by 3 times 3, and we just look at the two sets of factors, and the only common factor is 3. For the x's, we can look at the smallest power of x, and that will be the common factor, because they both have x squared. They both can be divided by x squared, so that represents our common factor. The x squared represents the common factor. And we can always think of it as the smallest of the two powers. If we look at the factor parts, well, we have only x squared on the left, so we can't have more than x squared as our greatest common factor. And then we could do the same for the y's. The lowest power of y is the greatest common factor. So between y4 and y squared is the common factor. So the greatest common factor is going to be 3x squared y squared. For lowest common multiple, what we want to do is we can look at the factors and see what is the lowest common multiple by seeing what factor is missing. So if we are looking at this from the red perspective, the red has a 3 times 4. It's looking over at the blue, and he has a 3 times 3. So the red is thinking that they are missing a 3. So we need a times 3 here. So that 3 times 3 times 4, or 36, represents the lowest common multiple of 12 and 9. And the same could be said from the blue perspective. The blue looks over at the red and sees that they have 3 3s. We have 3 3s. They have an extra 4. So they need an extra 4 over here to make it common, the same. Now, this strategy is really important because we're going to use this once we start doing rational expressions to get lowest common denominators. This is going to be really important that we understand how to get lowest common denominators by looking at factors. When we look at the x's, the red has 2 x's, the blue has 5. The red says it wants 3 more, so that has the same. So we have x cubed. Okay, so one way we can think of that for the variables is the biggest power is then going to be the power on the x for the lowest common multiple or the lowest common denominator. So at this point, my lowest common multiple is going to be 36x to the power 5. And then we can move on to the y's, and we can see that the y4 is the bigger of the two powers, so that should be the lowest common multiple of the y's. So for the y's, we have the blue is looking over at the red y and saying, well, he's got 2. I want 2 more to get the 4 y's that they have over there. So y4 represents my lowest common multiple. So 36 x5 y4 is the lowest common multiple. If these were denominators of fractions, that would be the lowest common denominator. For this one, there's a couple ways to do this, but one way is to think of this as dividing and distributing the divide. So I have a plus and minus. I want to distribute across the plus and minus. So this divisor needs to distribute to those 3 terms. And we could then show this as 3 separate fractions. So we should actually write out the fractions. So 12xy cubed over 6x squared y squared minus 6x squared y squared over 6x squared y squared, and we have to be careful of this one, plus 3x5 y squared over 6x squared y squared. Now, we have to be careful with these because we cannot cancel factors when there's pluses and minuses. Canceling in math is to do with times and divide, and we can only cancel when we don't have pluses and minuses involved. So by separating into 3 separate fractions, now I have one fraction in green which has no plus or minus, a fraction in blue with no plus and minus, a fraction in red with no plus and minus. So now we can simplify. So 12 divided by 6 is 2. X over x squared means I have an extra x in the denominator. Y cubed over y squared means I have an extra y in the numerator. So there's my fraction. This next one we have to be really careful because everything cancels out. But when we cancel everything with times and divide, we're always left with 1. So the biggest mistake that we see is that we get 0. There's no 0. 0 happens when we cancel with plus and minus. These are fractions. This is times and divide, so we're going to cancel times and divide and always be left with a 1. For the red part here, we have 3 over 6 simplifies to 1 over 2. x5 over x squared is x cubed. On top, the y squared cancels with the y squared. Okay, that's going to be left with 1. We don't need to write the times 1, just like we don't really need this times 1 here either. But that's going to be left with x cubed on top, 2 on bottom. So I can kind of simplify this to 2y over x minus 1 plus x cubed over 2. And again, we don't cancel factors until we have times and divide. When we separate into 3 separate fractions, we can simplify each one of those fractions individually.